today we will solve this question given on the board. So our question consists of this diagram in which there is an NMOS and we can identify that this is an NMOS by looking at the arrow, and there is a resistor and our gate voltage is given as 2 volt, our source voltage is given as 0 volt, and our drain voltage is given as V0, that is output voltage, and at the top we have 5 volt. So our W by N for this NMOS is given as 10, mu n COX is given as 200 microampere per volt square, threshold voltage for that NMOS is given as 1 volt, and we have to find the output voltage for two conditions. First condition is that when R is equal to 1 kilo ohm, and this is R, this resistor, when R is equal to 1 kilo ohm, and second condition is that when R is equal to 4.5 kilo ohm. So first let us see what is VGS. VGS here we can clearly see that 2 minus 0 volt. So VGS equals to 2 volt. And what will be our VDS? VDS equals to V0 minus 0 volt. So it will be V0. And our VT is given as 1 volt. And since we have to find this V0, then how will we find this V0? Here we can see that a current will flow through this resistor, and so our equation will be like 5 minus V0 equals to ID into R. This current will be ID. We know that the potential difference is equal to current into resistance. So using this equation we will find the value of V0. But here we can clearly see that our R is given, that is 1 kilo ohm, and we have to find V0, but there is one more unknown, that is ID, drain current. And for drain current we know that there are two equations, one is for saturation region and the other one is for linear region. So we need to find out that the NMOS is whether working in saturation region or linear region. So for that we will first assume that it is working in saturation region, and then at last we will verify whether our assumption is right or wrong. So let us assume that NMOS is working in saturation region. This SAT is for saturation. So let's assume that NMOS is working in saturation region. So what will be the current equation? Current equation will be half into mu n COX W upon L VGS minus VT whole square. So we will put the values. Half into mu n COX is given as 200 microampere. So here we will write 200 into 10 raised to power minus 6, because micro means 10 raised to power minus 6. And W by L is given as 10, so here we will write 10. And VGS is 2, so 2. And VT is 1, so 2 minus 1 whole square. So it will be this 2. Cancel this 200. So we will be left 1 milliampere. 1 milliampere will be the drain current. So what will be our output voltage using this equation? V0 equals to, from here we can write that V0 equals to 5 minus ID into R. So now we are solving for the first one, R is equal to 1 kilo. So putting the value of ID as 1 milliampere, that is 10 raised to power minus 3, and R, that is 1 kilo ohm, and we can write it as 10 to the power 3. So 10 raised to power minus 3 into 10 raised to power 3 will be 1. So V0 will be 5 minus 1 equals to 4 volt. Now we will verify whether our assumption was right or wrong. What is this V0? This V0 is VDS. So first let me remove this. So our V naught is 4 volt, that means our VDS is equal to 4 volt. And for identifying the region, we need to compare the VDS and VGS minus VT. So our VDS is 4 volt and VGS minus VT is equal to 2 minus 1, that is 1 volt. So here we can clearly see that VDS is greater than VGS minus VT, and this condition is for saturation region. So we can say that our assumption was correct. Assumption is correct. So whatever we found the value for V naught using this assumption, that value of V naught is correct. So our final answer for number 1 is that V naught equals to 4 volt. This is the correct answer for this question, number 1. Now we will see what happens when R is equal to 4.5 kilo ohm. Again the same thing is there, that VGS will be 2 volt, 2 minus 0. VDS will be V naught minus 0, that is V naught. VT is equal to 1 volt, it is given. And again we will have the same equation, that is 5 minus V naught is equal to ID into R. That means V naught equals to 5 minus ID into R. Now again we will assume that our MOS is working in saturation region. So let's assume that NMOS is working in saturation region. This sat is for saturation. So again what will be our current equation? ID equals to half into mu n COX W upon L into VGS minus VT square. Again we will put the values, half into 200 into 10 raised to power minus 6 because micro is given, and W by L is 10, VGS is 2 and VT is 1. So again we will get the ID as 1 milliampere. Again we will put this ID into this equation. So V naught is equal to 5 minus, in place of ID you will put 1 milliampere, that is 10 raised to power minus 3. And in place of R, now we will put 4.5 kilo ohm. That means 4.5 into 10 raised to power 3. So this will give us 5 minus 4.5, and that will be equal to 0.5 volt. So this time we got V naught as 0.5 volt, and this V naught is our VDS. Now we will verify whether the assumption is correct or not. So we got V naught as 0.5 volt. So here we will write that VDS is equal to 0.5 volt. Now we will see VGS minus VT. VGS minus VT is equal to 2 minus 1, that is 1 volt. And this time VDS is less than VGS minus VT. And this is the condition for linear region. So we can say that this time our assumption is wrong. So whatever we got the value for V naught, that is also wrong because our assumption is wrong, because we assume that our MOS is working in saturation region, but in reality it is working in linear region. So we will now go for assumption of linear region. So let us assume that NMOS is working in not saturation, this time linear region. And we will write the equation for drain current for linear region, and that is mu n COX W by L into VGS minus VT into VDS minus VDS square upon 2. Here we have two unknown variables. One is ID and the other one is VDS. Because what is VDS? VDS is V naught. So both are unknown. So we need two equations for this. One is this one and the other one is this one. We will use both. So in place of VDS we will put V naught. ID is equal to what? From this equation first, we will write what is ID. So from here, if we see what will be our ID, we can write that IDR equals to 5 minus V naught. So what is ID? ID is equal to 5 minus V naught upon R. So we will use this value of ID here. So we will put this 5 minus V naught upon R in the LHS side. 5 minus V naught upon R. And we know that what is our R? R is 4.5 into 10 raised to power 3. So we will write that also. And in place of mu and COX we will write 200 into 10 raised to power minus 6. And in place of W by L we will write 10. Then VGS minus VT is 1 because 2 minus 1 1. And in place of VDS we will write V naught. And in place of VDS again we will write V naught. So V naught square upon 2. So if we take this 4.5 into 10 raised to power 3 in the RHS, what will we get? 4.5 into 2, that will be 9. And then 3, 6. Yeah, so it will be 9 only. And then 9 into V naught minus V naught square upon 2. So we will have to solve this, like 5 minus V naught is equal to 9 V naught minus 9 V naught square upon 2. Now if we solve this here, what will we get? 10 minus 2 V naught is equal to 18 V naught minus 9 V naught square. So 9 V naught square minus 20 V naught plus 10 is equal to 0. So from here, if we solve for V naught using quadratic equation, we will get one value as 1.46 and the other value will be 0.76. But we can't say that the value of V naught is means two values are there for V naught. So we have to verify again which one is correct. So how will we verify this? Again we will verify this using the condition for regions. Like we saw that when our R is equal to 4.5 kilo ohm, it is not in saturation region. So we will verify that if these values get verified for saturation region or for linear region, and if any of them says that our MOS is working in saturation region, that will be incorrect. So first we will take 1.46. Now let me remove this. Okay, so our V naught is equal to 1.46. So we will write that VDS equals to 1.46, and we know that VGS minus VT is equal to what? Here 2 minus 1, that is 1 volt, and here we can see that VDS is greater than VGS minus VT. That means it is saying that it is working in saturation region, because this is the condition for saturation region. And we saw that in the second question our NMOS is not working in saturation region. So that means this value of V naught is incorrect. So V naught is not equal to 1.46. Now we will go for this one, 0.76. We will verify this one also. So if we write here VDS equals to 0.76 and VGS minus VT, we know it will be 2 minus 1, that is 1 volt. So here we can see that VDS is less than VGS minus VT, and this is the condition for linear region. So we can say that our assumption for linear region was right. Assumption is right. And our final answer will be that V naught equals to 0.76 volt. So this is the answer for this question, this second number. Hence the final answer for both the question is that for first one the answer is that V naught equals to 4 volt. The answer for the second question is that V naught equals to 0.76 volt. So these are my answer. So this is it for this video, and we will discuss some more questions in the next video. Thank you.